All right, everyone. So, welcome to Monday, January 10th. Today, unfortunately, I'm not in school, but we are going to still move forward because I really want to get started on chapter 2, which is our inequalities chapter, and I'm so excited to get started on it finally. I thought I'd still start with a little warm up here. The joke of the day is, where do snowmen get the weather report? So if you think you know what the answer for that is, write it on the top of your notes. Where do snowmen get their weather report? Write your answer for that. And then I want you to think about, would you rather have a snow day and stay home or have an extra vacation day in the summer? Like an extra summer day at the end of the summer, I guess. Personally, I think, while I would love to have an extra summer vacation day, it is always nice to have those like surprise snow days in the middle of the year where you didn't think you're going to have a day off, and then it's like, woo, I have a day off all of a sudden. So I like having those. I don't know about you guys. I hope everybody went out on Friday and Saturday and enjoyed the snow. It was a really beautiful snow, and it wasn't too much that it made it difficult to walk in, but it was definitely enough to go sledding. It wasn't great for making snowman. I don't know if you guys did that, but we did not make a snowman at my house. But we did do some sledding, which was fun. All right, so we're going to get right into it. So take your notes, please. Make sure you have a pencil, and you might want a calculator for what we're doing today. I don't think you're really going to need one, but you can have one handy if you'd like. If you need to, you can always pause the video at any time to get any supplies that you need, or if you need to finish it later or whatever, it's not a big deal. You can always come back to it and finish it, after school or whatever if you don't finish it during the class period. But I'm going to try to keep this to about 20 minutes or less because I think that's fine. I don't think you need to do like an extensive amount, but I definitely want you guys to have an introduction to this so that we can really jump right into it when I see you again on Wednesday, unfortunately. Oh, no, actually, I'll see you Tuesday. We don't drop tomorrow. So perfect. Okie dokie. Here we go. Okay. So hopefully you have these notes in front of you. If for some reason you don't have these notes in front of you, you can always print them up in the classroom. If you take one of the laptops that are in the back of the room out, you can log into that, and that prints to the printer in the room. Alternatively, you can always go to the library and print these out, but the sub should have a copy of these and you should be good to go. They're in the classroom already. I left them there last week. All right, so chapter 2 is all about solving linear inequalities, which means we're going to be dealing with inequalities that fall on a number line in this case. Later this year, we're going to be dealing with inequalities that are on a coordinate plane, but right now we're just going to be thinking about things that are on a number line. So, first of all, in terms of a definition, an inequality is a mathematical sentence that compares expressions. So that word is inequality. I'm using my tablet here. It's not perfect, but it's pretty good. It works out. All right, and then we have some key phrases that we can use when we see math statements that are written out in sentence form that we're going to then use to translate into inequalities. So you can see the 4 different types of inequality symbols at the top of the screen. All these symbols here. And you've probably seen these symbols before. You've probably utilized these symbols before. And now we're just going to be taking them, hopefully, to sort of the next level. So the first symbol is our less than sign. So obviously a key phrase that we will see in sentences is just less than. And the sign next to it, we see the greater than sign. So we might also see just the words greater than. And then the symbol next to that is a less than sign with a bar under it. So that means that not only is it a less than, but it also means it could be equal to. So there's an option there. It's an and or sort of situation. So we say less than or equal to. And then the last one is a greater than sign with a bar under it. So again, it means it could have a value that's less than it, or greater than it rather, or it could be the value that's equal to it. So that will be greater than or equal to. All right, so let's talk about some additional phrases for some of these. Some of them have way more phrases than others. A typical one that you might see for that first one, the less than, you might see less than, you might see fewer than. And then on the flip side, when we see the greater than sign, we might see the words greater than, or we might see the words more than. And then we get into our inequalities, our less than or equal to and our greater than or equal to. And this is where we have some additional phrases that can be a little tricky because they're should write in the example of x is less than or equal to 5. So if we were dealing with a word problem and it was saying something like John has no more than 5 apples in his basket, that would mean that John has maybe 5 apples, maybe he has 4 apples, but he doesn't have any more than 5 apples. So in that case, we would have a scenario where whatever's in his basket, his x is less than or equal to 5 because it's no more than 5. It's not 6 apples, not 7 apples, but it could be at least 5. So no more than, oops, no more than 5. The other way we could explain it is to say that he has at most 5, meaning that he could have 5, but he could have any amount that's smaller than 5. So meaning that he's got 5 or less. So no more than 5, or we could say at most 5. So at most would be our other phrase we could use here. Once we remember those, now it's kind of easy for us to think about what would the opposite be now for greater than or equal to. So when we're talking about our example for greater than or equal to, we're going to say x is greater than or equal to 10. And we're going to think about a scenario where your parent says, okay, I want you to go to the store and I want you to get a gift for so and so in your class, maybe Miss MC. And they said, you know what? We want you to spend at least $10. Meaning you better not spend $9, you better not spend $8. You need to spend at least $10, meaning $10 or more. Greater than $10. So in this case, instead of saying at most, we say at least. So greater than or equal to, we say at least. We could also say, and don't you dare spell any less than. So no less than would be our other phrase that we could use to describe a greater than scenario. So no less than 10. No less than 10 says that I can't spend 9. I have to spend 10, 11, 12, 13, 14, anything greater than 10 or including 10. All right, so I think that's probably the trickiest part of this whole lesson is just figuring out those phrases. And we're going to move on now to starting to apply them. So if you need to pause this for a second to make sure you have that all written down, feel free to do that. I'm going to slide this down. Ooh, I just realized that I spelled greater with an H in there. Why did I put an H in there? Let's fix that. It should be greater, not greater. Greater. Now my A looks funny too. Let me fix that whole thing. Greater. Okay. Greater than or equal to. No H in that word, silly. All right, writing inequality. So for each sentence, we're going to write an inequality. We are going to break this down into its parts. You'll notice that I highlighted some of it here in your notes, but in the future, feel free to box things up, underline them, double underline them, squiggly line them, whatever is easiest for you to kind of help you visualize the parts of this equation or inequality rather that make up, the two expressions that are being compared. So, example 1, we have a number w minus 3.5 is less than or equal to negative 2. So, less than or equal to, again, we want to look back up at our table. Less than or equal to is this guy. So, we're going to make sure we start off by putting that symbol down on our line. So, we've got less than or equal to is our inequality. And now we want to look to see what's being compared with that less than or equal to sign. So on the left-hand side of our word, our sentence here, they say a number w minus 3.5. So on the left-hand side of my inequality, then I'm going to have this idea of w minus 3.5. W minus 3.5. That one's pretty straightforward. And then on the right side of my inequality, and here is my inequality in my sentence, on the right-hand side, all I have is negative 2. So there's not any expression or work that we need to do there except for just write negative 2. So here we have translated this sentence to the inequality. And that's all they asked us to do here is just to write that sentence as an inequality. We don't even need to solve it or anything. We're just leaving it as translating it from words to numbers and variables. All right, take a look at the second example. 3 is less than a number n plus 5. So again, we're going to think about what is our inequality symbol first. Is less than means we're going to be using that less than sign. And then we look again on the left-hand side. They just gave us the number 3. And on the right-hand side of our inequality or in the sentence says a number n plus 5. So that means I'm going to have an n. I'm going to be plussing or adding 5. So n plus 5. So those are pretty straightforward. No real tricks in those. Let's see what we have on the next page. And again, at any point if this is going too fast, you can always pause it and keep writing down whatever's on the screen. So the last example here is 0 is greater than or equal to twice the number x plus 1. So greater than or equal to was our inequality where we had a greater than sign and a bar on the bottom, meaning that we have an equal part, and then we have the greater than part. So I'm going to first start by putting that on my line, greater than or equal to, and then look what was coming before it. So in this case, it was just 0. So 0 is greater than or equal to twice a number x plus 1. So twice a number means that I'm going to have that number twice or 2 times. So that means 2 times x plus 1. And that's all we have to do there. All right. I want you to take a few minutes now to practice this. You have 4 different ones that you need to fill in. I'm going to give you a few minutes to do that. So pause the video now, please, and write them in. And then we will go through those answers together. Okay, so hopefully you have gone through and written these sentences as inequalities. Let's go through the first one together. A number B is fewer than 30.4. So fewer is another one of those phrases that we used for less than. Oops, I just drew a greater than. Sorry, I meant less than. Okay. So B is less than 30.4. Second one, -7/10 is at least. And at least meant that something had to be that number or bigger, right? At least was that one where we talked about go buy Mrs. MC a gift that's $10 or greater is at least $10. So that is one where we talk about greater than or equal to. So greater than or equal to is our at least. And then we're looking at the two things that are being compared. So we've got -7/10 is at least twice a number k, so 2k minus 4. All right, for the next one, 13 is at least, again, we've got that greater than or equal to, so greater than or equal to, we said 13 is at least. The difference of a number v and 1. Now, who remembers what difference is? What operation is difference? Hopefully you remember that that is subtraction. If you didn't, I want you to star that right now and remember that. Put that in your memory, but definitely write that down. That difference is subtraction. So the difference of a number v and 1 means that we're going to take the v and we're going to take the 1 and we are going to subtract them. All right, the last one there, a number x is greater than is a nice straightforward greater than sign, 3. So x is greater than 3. I'm going to redraw that with kind of a sloppy greater than sign. There we go. Alrighty. Okay. So check over your work. Make sure you have those correct. Or if you make any corrections that you need to make. How can you use an inequality to describe a real life situation? So I've already given you some examples here. I'm going to put this as a question in the ed puzzle, but you should also write it down on your paper on how you think you could use this in real life situations. I already gave you the example of, buying a gift for somebody, putting apples in a basket, having a certain amount that you need to have or a certain amount that you can't have more of. Any of those things, you can look back at our table to give an example as well with those little phrases that we use for the inequalities. And then we're going to come up with some real life statements. So I'll give you a minute to come up with that question of an example from real life. Oops. All right, so let's take a look at these examples down here. Write a real life statement that involves each inequality. So our first example is x is less than 3.5. And my example phrase that you could use is a diner keeps the price of a pie under $3.5 or $3.50. So you can change that to money. In this case, I had 3.5. I changed it to $3.50. Same idea. It's still 3.5. All right, so here we are dealing with x is less than or equal to 6. And it might be helpful to go back to this table here and look again at what are our phrases for less than or equal to. So less than or equal to, we can use just the phrase less than or equal to. We can say no more than, or we can say at most. So we have the options of less than or equal to, we could also say no more than, or we could say at most. I tend to like the at most, right? When you go to the store, I want you to get at most 6 potatoes. I want you to get at most 6 boxes of tissues, at most 6 cans of soda, whatever it is that you want to get. but we want at most this one. So I'm going to say by at most 6 apples. The second inequality now is x is greater than -2. And when we deal with negative numbers, that's when it could be a little bit trickier. But a lot of times we have negative numbers in the real world and things like um, temperature and like digging a hole or something where we have something that's missing, right? Or even owing somebody money. All these are different kinds of scenarios we can use. For the greater than symbol, we talked about just using the phrases greater than, greater than, and more than. You could use other phrases. There are definitely other phrases out there. I can't think of any off the top of my head, but there definitely are other ways we could explain this. But what we are going to use here, I'm going to talk about the temperature. So hopefully the weather this coming week will have temperatures that are more than -2 degrees. So the temperature is more than -2 degrees Fahrenheit. So those are just some examples you could use to describe these inequalities with a real life connection of how we can use those in the real world. All right. So the last part of this that we're going to talk about is sketching the graphs of these linear inequalities. So the graph of a linear inequality a solution, not a graph. A solution of an inequality is a value that makes the inequality true. So thinking back to, again, when we were saying, how can we remember what those phrases are? If we were talking about something like that, x is less than or equal to 5, I think about what are my phrases. It has to be at most 5 because it can't be a number that's bigger than 5, right? It has to be 5 or 4 or 3 or 2 or 1. So at most it could be 5. So we're thinking about the same things here in terms of like what are the possible solutions that would be true for something that was less than or equal to 5. So what are the numbers that are less than 5 or equal to 5? That's what we're going to be thinking about here when we sketch these graphs. An inequality can have more than one solution. And that's because it's not just equal, right? We're saying that it's possibly equal in those greater than or equal to and less than or equal to situations. But we're also saying that it could be less than that value or it could be greater than that value, depending upon our inequality symbol. And the set of all of our solutions is what we call a solution set. So all those possible values that make this statement true are what we call our solution set. So we can test our possible solutions if we're given some options. We can test those possible solutions by substituting or plugging in that variable into the inequality and solving to make sure it actually makes a true or a false statement. So in this table, I'm going to show you how we can practice doing that, and then we're going to cut it there for the day, and then you'll be done with your notes for today. So we're going to plug in each of these values into this inequality of x plus 5 is greater than or equal to -2. So when we have x plus 5 is greater than or equal to -2, we're seeing is it possible that x could be the value of -1? Well, let's test it out. So instead of writing x plus 5, I'm going to write -1 plus 5 is greater than or equal to -2. Once you have that written out, we are then going to just simplify this portion of the inequality that has to be simplified, right? That -2 is not going to change. That's going to stay there. We're not going to try to balance anything here. We're just simplifying what we are given. So if I subtract or add, really, -1 plus 5, I should just get 4, bring down our inequality sign, bring down the -2, and is 4 greater than or equal to -2? Is 4 bigger than or equal to -2? 4 is bigger, so it is a true statement, which means that -1 is a solution. All of that information has to be written down that I just did, the true and that -1 is a solution. If you just write true, you really only half answered the question. Okay. All right, we're going to repeat those same steps now with -7. So -7, I'm going to put it a little bit higher in my box so I have a little more space here. -7 plus 5 is greater than or equal to -2. And again, I'm only going to be solving the right-hand side in this case. I'm sorry, left-hand side in this case, because that is where the only part of my inequality that can be solved or simplified. So with that in mind, what is -7 plus 5? We can do that on our calculator, or if you want to do it in your head, you should get -2, which is greater than or equal to -2, because these things just come down. That greater than or equal to sign and the -2 are just coming down. So is -2 greater than or equal to -2? It's not greater than it, but it is equal to it. So this is still true. -7 is a solution. And make sure that you're remembering that the number you were putting in was -7, not -2. That was the number you got out, but what we actually plugged in was this -7, just like in the previous problem we plugged in that -1. So -7 is a solution. Okay, I think you get the idea. I want you to continue with the next two boxes, and I'm going to include in the Ed puzzle that I want you to test these out and tell me whether these are, in fact, solutions or not. I'm going to set them up first. So -8 plus 5 is greater than or equal to -2, and 2 plus 5 is greater than or equal to -2. So you are going to continue to then simplify these. Simplify those highlighted portions, and then on the next box you should be writing whether these are in fact true or false. Oops, true or false words. Blah 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 is a solution, or blah 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 is not a solution. So -8 is or is not a solution is what you should have written there, depending upon your answer. So if you find out that it's true, then it is a solution. If you find that it's not true, then it is not a solution. Is or is not. You need to decide. All right. So that's it for today. I was a little bit longer than I wanted it to be, but I think we got through some information so that we can at least hit the ground running tomorrow and just keep going and plowing away with our inequalities. Thank you so much for the hard work that you girls are doing today. I really appreciate your attention to this and that you get your work done. And I hope to see you all tomorrow. Take care. Have a great night.